During certain time periods at JFK Airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minutes and 5 minutes. Let's see what this problem is about. So you have people at JFK Airport, specifically at the security checkpoint, that are waiting between 0 to 5 minutes. This problem would be about people waiting, let's say, zero point 0.5 minutes. Someone could wait 1.6 minutes. Someone else could wait 4.3 minutes. The reason I created this sketch the way it looks like is because we're told that the frequency is uniformly distributed, which means that these columns that you see here all have the same height. Or in other words, in terms of this problem, the waiting times for these people are all pretty similar. And what do I mean by this? In this case here, you have three people waiting for 5 minutes. In this case, you have two people waiting for 4.3 minutes. In this case here, you have three people waiting for 1.6 minutes. So therefore, you see that the waiting times for all these people here are uniformly distributed. They're very similar. But how do we tackle this in terms of a graphical representation? So this is what we do. For this problem, we create a graph very similar to the one that I'm sketching here. In this axis, we're going to write what the range of waiting times are. And so this is going to be waiting times. So you'll have some, the different waiting times would be everywhere between 0 to 5 minutes, but I'm going to put in these tally marks to represent the different values. So these would be waiting times, but I'm also going to look at this as a length, because you're going to see in a moment why I would refer to this as a length. Because eventually this is going to become a rectangle and we're going to find the area under a rectangle, we need to determine what the height or the width is. The height or the width will always be the reciprocal of your maximum value. The maximum value here is 5, therefore the width or the height is 1/5. Had this value been 6, this would have been 1/6. Had this value been 8, this would have been an 8. Now let's look at this specific question. Find the probability that a randomly selected passenger has a waiting time of at least 2 minutes. What are we looking for? We're looking for individuals who have waited for at least 2 minutes. Or in other words, values that fall somewhere in this area. You're looking for the probability of randomly selecting some value that falls in this area here. First thing we're going to do is determine what the specific length for this rectangle is. Well, that specific length is 3. And why is that 3? Because it's 5 minus 2. And we use this information in the following way. In order for us to figure out the probability of picking one of these values, we're going to find the area inside that rectangle. And the formula for the area of a rectangle is length times width, or length times height. What's the length of this specific rectangle? Well, that's 3. What's the height or the width of this rectangle? That's 1/5. 3 times 1/5 is 3/5, which is the same as 0.6, which is the same as 60%. So what I've done here first is created an illustration for you to understand what we mean by uniform distribution, I've demonstrated the graphical representation of the problem, and here is the computation. So the last part is to interpret this result. What does this result mean? So this result means the following. The probability of randomly selecting a passenger with a waiting time of at least 2 minutes is zero point 0.6. In other words, there is a 60% chance of randomly selecting an individual who's waited for at least 2 minutes, or in other words, 60% chance of selecting a value in this area.